I figured if we're going to do it, we may as well, have the ability to have all the people that might contribute or think about contributing, or at least want to understand sort of how we work with Arkouda. So today is really about that user facing part. How does a user interact with Arkouda? How is it similar to pandas and NumPy, and maybe some places where it might differ, right? So, okay. And hopefully we can get this. Also, we don't make too many mistakes, so the recording comes out okay. Okay, so I see some people I know. That's good. That's good. And I see some people I don't know, which is good too. That's awesome. I know I've been, people have bugged me a little bit every so often to put together some training. And a while back, I mean, it's been over a year, maybe a year and a half since I gave the Chapel team sort of a top to bottom walkthrough of the code in the server and a little bit of a demo with the LANL NetFlow to sort of show sort of the whole path from one end to the other, right? That the code represents. It's a little deceptive, when you think about it, because it looks, you're going to see it looks really simple in some ways to use. And there are some gotchas still that you have to make sure that you don't sort of go overboard on. But anyway, I don't know, Bill, do you, I guess we're 4 minutes in. I think we should probably just get started because people are going to have questions, and we should, do you want to share your screen, Bill, and maybe walk through some stuff?
Let me share the screen. All right, is that coming through?
Yeah, it looks good.
Okay, so I'll take it from here. Yeah, as Mike mentioned, today's session is all about sort of what Arkouda feels like from the user perspective, and just to give a little tutorial or demonstration of how to use Arkouda. So if you don't know much about Arkouda, there's a number of talks, and some of them have been recorded, and they're linked on the Arkouda GitHub repo. There's resources for you to sort of get a high-level overview of Arkouda if you don't have one already. But Arkouda is often spoken of in the same category as NumPy and pandas. And just wanted to show and reiterate with this notebook that Arkouda is not intended really to be a replacement for these packages. It's more like an extender for them. So this notebook shows a lot of sort of interoperation and integration between Arkouda and pandas particularly. That is pretty representative of the workflows that we see users frequently using with Arkouda. These notebooks, because I'm running this on my laptop, these are sort of meant to be small or medium scale demonstrations of Arkouda capability. But these notebooks are the same kind of thing. You could run the same notebook on a multi-terabyte data set on several nodes of an HPC.
So, Bill, let me interject something at this point. I don't know how many people on the call know, but there's two things that Arkouda really does, and one is it breaks the 32-bit integer index limit of NumPy. Right, NumPy is all the NumPy arrays are limited by a 32-bit index. And am I coming through okay? And it also allows us to span multiple servers. So we've broken the sort of shared memory paradigm also with the arrays. Anyway.
Yeah. Yeah, our goal with Arkouda was to basically take common operations that are computationally intensive in pandas and scale them up from a single workstation or server running on about 500 million rows up to several 100 billion rows in distributed memory. So what we're going to do today is divide it into two sections. I'm going to show you how to sort of prepare data for loading it into Arkouda, because that's always the messiest part of data science, is just getting your data cleaned and formatted correctly. And then I'm going to go through some sort of toy data explorations on this New York City taxicab data set. So this notebook kind of assumes, if you're going to run this later yourself, this sort of assumes that you've gone and downloaded the New York City taxicab data set, and there's links here in the notebook to those. It also assumes that you have cloned the Arkouda GitHub repo and actually built Arkouda, which there are instructions for that on the repo. But all that is assumed here. So the first thing to do is this New York City taxicab data comes in CSV format. And there are really two methods for getting it into Arkouda. The first method is you can load data, like text-based data, in Python, like with pandas, and then transfer it across the socket to the Arkouda server. This works well for small data, like small enriching data sets. We'll see an example of that sort of halfway through the notebook. But for large data, what you really want to do is get your data in HDF5 format, which is Arkouda's I/O format. The Arkouda repo comes with a script that will convert from CSV to HDF5, and this is really the best option for large data sets. So a couple words about this real quick, because this is just so important. In HDF5, there's only 3 types really that HDF5 files support that Arkouda can read, and those are integers, floats, and then there's a custom string format that this converter will output. So when you convert your data, it has to all be in one of those 3 things, and then once you get it into Arkouda, you can cast it or convert it to more specific data types like booleans, and there's types for date time and time delta. But on the file system, it has to live as an integer, a float, or one of these custom strings arrays. In general, it's best, we found with all of our use cases in on our internal mission, that integers are the best. If there's a sort of natural or native way to represent your data as integers, they are the fastest and most versatile type. You can use them with group bys and all these other specialized data types. So prefer integers if you can. Okay, so I'm going to show an example of using this data converter on the New York City taxicab data. So I downloaded the data set, and here is the first 10 rows of it. You can see there's fields like vendor ID, which is an integer, and then pickup and drop off date times are string formatted dates and times. There's floats also, and then there's this yes/no column that's eventually going to be a Boolean, but that we're going to convert to integers first. So the way to use this converter that comes bundled with Arkouda is you define essentially a format file that's a Python module that takes the exact same options as the pandas read CSV method. So those of you who have used pandas will find this structure familiar. If you haven't, the pandas documentation is a really good place to look for information on this stuff, because it calls pandas under the hood. But anyway, you define things like what's the separator in your data. In this case, it's a comma. You can give it column names for columns that are dates, and tell it to infer and parse those as dates. And then you give it these converters. Each column that you want to end up as a particular data type, you should specify a converter for it. And for example, I have this yes/no to int converter that converts it this yes/no column to a 0 or a 1, and then this null int column, which converts to an integer where erroneous values are represented as -1. Anyway, then the last thing you have to do is register all your formatting options in a global options dictionary. So once you've done this and you have your format file, then you can call the converter, which this is an example of how you'd call it on the command line. You give it the formats file that you just wrote, and then the name of the format that you defined, and you call it on the CSV data, and it will show you what it's going to do. It'll show you it picks up these 18 columns, and these are the data types that it found for them. And this, I won't run it here. It runs in about 2 minutes for this New York City taxicab file, which is on the order of 500 megabytes. So once you've done that, your data is in HDF5, and now it's ready to read into Arkouda. So at this point, you'd go into a terminal, which hopefully will show up on my screen, and you have to start the Arkouda server, which just, if you've built it and if you've added it to your path, is just Arkouda _server.
Are you going to share the the terminal window? Or
if it's not sharing, I don't know how to make it share.
Okay.
So, but really, it's just you run Arkouda _server in a terminal, and that's it.
So, hey, this is question. So it looks like you are sharing on your browser. If you are comfortable sharing the whole desktop, the terminal will pop, I think.
Let me try that. All right, so this is what I did in the terminal. Can you all see the terminal?
Yeah.
All right, so you run the Arkouda server executable that you get when you build Arkouda, and it gives you this splash screen that tells you the host name and port that the Arkouda server is listening on. I'm just running it on my local machine, so then you can come back to your notebook and you import the Arkouda module and you connect to the server using that host name and port, that URL that the server splash screen provides you. And it'll show this nice thing, you connected to Arkouda, and then we can read the data that we have just produced with this converter. So it started as a CSV file, and now it's a .hdf file. And this one on my laptop takes 3 to 5 seconds to read for that ½ gigabyte file. And then remember, I mentioned that the only HDF5 types that Arkouda supports are integer, float, and this custom string. But once you've read those in, you can do conversions after the fact to more specialized data types, like the pickup and drop-off times. There's an Arkouda datetime class for those, which I'm going to convert the top to. And then for Booleans, if you just you test for equality, that will return a Boolean. So once you do those conversions, you get a what's sort of like a data frame. It's just a dictionary, but the keys are column names and the values are these Arkouda arrays that live on the Arkouda server outside of the client. And you can see the pickup and drop off times are date times. Everything else is either an integer or a float. And oh yeah, and the thing we converted to a bool is now a bool. Okay, so this just computes the number of rows and how many bytes your data is taking up. So we got 6 million rows and 880 megabytes of data. So that's a quick run through of data conversion and loading. And I guess let me pause here because I know that it's a big subject. Let me ask if there are any questions. Okay.
I guess nobody wants to be the first, Bill, I guess.
Yeah.
But so I think that this subject of data conversion we could spend an hour on just all by itself, right? And
right.
If anybody wants more in-depth discussion of it, we should probably push that off to another time or another discussion, unless someone has a short question, right?
So, hey, this is Kostin. I actually had a short question in this area. So, your plan, I mean, as far as how you're gonna use this infrastructure, how many other data formats and structures do you think you may need? Because what I'm thinking is we have a lot of experience sort of synthesizing data transformation engines from whatever Python style in-memory data structures or tables there are to some other HPC internal formats. So if you need a lot more sophistication than these types of transformations, I think it's available. But I think you guys need to articulate what are your formats of interest, on what kind of structured data you want to look at and what type of.
Right.
So yeah, that would be very helpful to us, for example.
Oh, okay. Yeah, I think there's a separate question or distinction between these sort of data types for individual elements versus data structures, as more of a global kind of data layout thing. And certainly there's a lot of ground to cover with data structures. And I think that, so in Arkouda proper, we've designed it to only really support block distributed arrays. But we want Arkouda to be an integration point for other HPC packages. And so having the ability to transform those block distributed arrays into other data structures that are suited to specific tasks would be a good goal and an important thing to talk about at some point, probably outside the scope of this tutorial though.
All right, but because I'm just curious because this is, for example, one of our areas of interest. So if you guys perceive a need in this area, it's good to know.
Okay.
Thank you.
Thank you. Okay, so we'll move on, I think, to some exploration of the data. So the first thing is just calculating basic descriptive statistics. So Arkouda arrays have attributes for calculating the mean and the standard deviation and the min and the max, much like NumPy and Pandas arrays. So this is just a little function that calls all of them and prints them nicely. So you can do that kind of thing. Histograms, there's this function. So Arkouda has a histogram function, but it doesn't compute the bins for you. We've got sort of a a wrapper function that does that, but we need to move it into the main repo. But anyway, this is just a function that uses the Arkouda histogram function to compute bin counts of x over an integer number of bins. And then the rest of this function comes back to NumPy, and depending on the D type, computes the appropriate bins and then plots it using matplotlib. So if you do this, for example, for the fare amount, you can see on a log scale, it looks kind of like that. There's a big, roughly normal distribution maybe of fares, or with interestingly some negative fares. So
hey, Bill.
yes.
You might want to point out the 2ND array call.
Yeah, thank you. I forgot to mention that. So the thing about this is an integration point between Arkouda and NumPy. H, when this line is called the ak.histogram, the return value is an Arkouda array that lives in the Arkouda server. Now this PLT, this matplotlib function, doesn't know how to plot an Arkouda array, but it does know how to plot a NumPy array. And so we call a method of the Arkouda array called toNdArray, which brings it back into the Python client as a NumPy array. And that's a very common idiom for using Arkouda, is you do some calculation on the large data set in Arkouda to generate a smaller result vector or result array, and then you bring that back to Python in NumPy or Pandas for either inspection or plotting or something like that. So that's what we've done here, and that's what this hist function does. So next kind of operation is a concept from MATLAB and its precursor in precursor languages, which is called logical indexing. This is a very useful paradigm in Pandas, where you can select rows of a data frame or elements of an array based on some condition. So here we're going to select the non-negative taxi fares. So we form this vector where the fare is greater than or equal to 0. And you can say, you can sum that Boolean vector and say how many trues are there and compare it to the overall size. You can see most of the fares are positive. So let's select only those, non-negative. Let's select only those non-negative ones and run that describe function on them. And you can see the mean and the standard deviation have changed a little bit, and the minimum is 0 now. So that's a way to sort of filter to a subset. And you can filter the whole data with this this little expression. It's a dictionary comprehension that basically says take every key value pair in your data and index it by this logical vector and return it as a new data dictionary. So that's what that does. Now everything in this data dictionary will have a non-negative fare. So then moving on to working with time data. So you remember we converted the drop-off and pickup times to Arkouda date times. Well, those sort of know how to combine with each other. So you can do things like subtract 2 date times to get a time delta. In this case, the ride duration, and it'll display nicely as minutes and seconds for you. And you can do minimum and maximum and stuff like that. And with some special casing for the data types, because matplotlib does not handle NumPy time deltas very well, you can plot histograms. And you see this kind of huge block between about 0 days and a day, and that with a bunch of outliers on top of that. Okay, so next we're going to talk about making a lookup table in Arkouda and applying that lookup table. So this is this sort of incidentally will demonstrate the other method of getting data into Arkouda, which is to read it in pandas or something like that in Python and transfer it over to Arkouda. So what we're going to do here is using pandas, we are going to read in a CSV file which comes with that taxicab data set, and it's basically a mapping from zone ID numbers, which are integers, to information about the zone, like what borough it is and what neighborhood it is, and those are human readable strings. All right, so we read in this table with pandas, and we do some tweaks to it to make it 0 up indexed and things like that. So this is all standard pandas stuff, and it produces a data frame with where each location ID is mapped to a borough and a zone and a service zone. And then we're going to turn that into an Arkouda dictionary using this function here, which basically just goes through the pandas data frame, and in most cases just calls ak.fromSeries on the column. And if the column is of D-type object, it tries to convert it to a string. So this is the same pandas data frame in Arkouda as a data dictionary. And then we're going to take this data dictionary and treat it like a lookup table and gather from it to enrich our data dictionary with not just location IDs, but location, the pickup borough and zone and the drop-off borough and zone. So first, we just want to make sure and verify that our location ID really is a dense 0 up index that includes everything from 0 to 265. And one way to do that is to compare it against this ak.arange. So this command generates just the range of integers from 0 to the size of the array. So we're comparing it against the arange and making sure that they're the same. And they are. So we can treat it like a lookup table. We won't get any index errors. So what we're going to do is we're going to say the pickup borough is going to be this lookup table borough indexed by the pickup location ID in the data frame, right? And same for the drop-off borough. And we're going to do the same thing for the zones. And you see those took a couple hundred milliseconds. And now we end up with, at the bottom of our data dictionary, pickup boroughs, Manhattan and Queens, etc., and zones, which probably a New York native would know what those mean, but I don't. Anyway, so that's enrichment with a lookup table. Now you can do lookups with a sparse table. We used a dense table here, where the lookup index was actually just a 0 up integer index. You can do lookups with a sparse table, but it requires some more logic that I don't have time to go into right now. But it is possible with things like in1D and group by. So that brings us to group by, which is probably the most powerful use case for Arkouda, doing group by on large data, because group by is really the thing you need if you want to, say, construct a graph, right? If you think about this data set, each row of the input data frame corresponds to a taxi ride. And most of the questions that you would want to ask of a graph don't have to do with rides. They have more to do with relationships between pickup and drop-off zone, or you might need time of day or something like that. And so there's this implicit conversion from the native domain that the data lives in to the domain that you care about when you're constructing a graph. Or it's the same thing when you're going to do machine learning and you want to compute feature vectors for the items that you're going to classify. Usually those items are not the actual rows of the data frame that you read in. You need to do some grouping and translate to the items that you care about. And group by is the workhorse for all those things. So this is just a simple demonstration of group by. Here we're going to group all the data by the pickup location ID and the drop-off location ID. And this, what this does under the hood is it lexicographically sorts the data by pickup location ID and drop-off location ID, so that the pairs are sorted, and then it finds the boundaries between sorted groups and keeps track of where those are. Now the group labels themselves are stored in this thing called unique keys as an attribute of the group by. So these are, pickup location ID 1 with drop-off location ID 1, and then pickup 1 with drop-off 50, etc.
So Bill, you can, I sort of consider this to be, we can use multiple columns in the data frame sort of as an aggregated key.
Mm-hmm.
Basically, that's really what it is, right? I mean, you have pairs or triples or something,
right? And
you're keying, basically, you're ordering everything or grouping everything based on those keys.
Exactly. Yeah, that's what this operation should be interpreted as. And then, often the key, the pair or the triple or whatever it is like a vertex identifier or an item identifier if you're doing classification. So yeah, oftentimes it's about selecting the kind of key that pertains to the thing you care about, and then grouping by that key, which can be multiple columns. So, let's say we wanted to construct a graph, a directed graph from pickup location to drop-off location. These unique keys here would be the source and destination vertices for the edges. And then there's, you could define weights in any number of ways, really. Let's say you want the edge weight to be the number of rides between that pickup and the drop-off location. Well, the .count method of the group by object will give you that. The group by object has several aggregation methods, and they all return the same kind of thing. The first thing they return is the unique keys, and then the second thing they return is the aggregated value per unique key. Right. So calling this by location.count, we get the source vertex, the destination vertex, and the weight for each edge. And you can see that here. So there's 638 rides between pickup zone 1 and drop-off zone 1.
So, can I ask a question here?
Yes.
So looking forward, do you have any examples of complex queries you want to run on data?
So often,
sorry, go on.
When you want, so I don't have more complex queries in this notebook, but typically those are just compositions of the kinds of comparisons and logical indexing that we saw above. Right, like say you wanted to find all the fares that were non-negative and the trips that were longer than a mile, right? You could compose those by saying fare greater than 0 and trip greater than or distance greater than 1, and then AND them together and use that as a logical index.
Okay, so the reason I'm asking, this looks like a lot of kind of structured SQL queries, because it looks like you're doing structured data, and it seems to me there's a lot of opportunity here to do query optimization on this end of the program before you actually specialize for the chapel.
So I would actually say, it can sort of look like structured SQL, but the problem here is that you've got a data scientist who actually wants to write a piece of code, and there's over 400 different operations in Arkouda, and expressing and Bill should chime in on this, but expressing the query is not really natural for them to do in SQL a lot of times. And they would much rather write a piece of code to express the query, right? So there was a query, I can't go into any detail, but there was a query where you could think about filtering vertices based on some kind of criteria that creates a set of vertices, and then that filter set gets thrown into some set of edges, and so there's a cascading set of multi-level group bys that happen, and then there's some set union and intersection and set difference and other things that happen in the code. So these things can get really complicated, and what could be a very short piece of Python code could literally, I've seen this happen when you try to recreate it in like something like SQL. It could be like 2 pages or 3 pages of SQL for 10 or 15 lines of something we could do in Arkouda. So it's really a different animal. Anyway.
And I would add that, sorry, go ahead.
So I wasn't suggesting SQL per se. I was suggesting applying the same techniques as far as whatever query filtering and table combination goes when you make the execution plan, adopting the same type of techniques, and not the SQL language itself. So there's a lot of knowledge in query planning there to minimize the number of intermediates, whatever, data table size, whatever it is. Yeah.
Sure.
We haven't found a huge need for that really, because the kinds of operations that we're using to do the structured queries like that almost never take longer than a second, even on many terabytes of data. And we don't see memory overruns from those kind of things. They're just not really the pain points in the Arkouda workflows. So we just, I mean, it's possible to do query optimization on those things, but and maybe down the road we'll run into a need for that, but we just haven't yet.
So I have the one thing I would add to that is in our workflows, we're trying to optimize the development time of something. So, we want to be able to construct a new graph or a new filter in 15 minutes at the Python prompt, basically. And that gives us the ability to, so what we're doing is we're minimizing the latency to the solution, right? And which includes code and people's thinking and statistics, right? And, and constructing the math that's appropriate. That doesn't mean that we can't take that result and construct a much more optimal thing if we're going to roll that into production, right? If we're going to roll it into a space where we're going to run it over and over again or something like that. Okay. Does that make sense?
Yeah, thank you.
Yeah. Okay, so the another kind of important concept is this idea of broadcasting, which is sort of a generalization of something that NumPy does, but in the way that Arkouda does it, we haven't really seen that in Pandas or NumPy. And this is, so I mentioned that kind of domain translation operation where you have to go from the rows of your data frame to the sort of group key that you care about. Well, going that direction is a group by with an aggregation. Going the opposite direction is what we call a broadcast, where you go from the grouped data back to the original data frame. And this can be pretty useful in a lot of situations. Here is just an example of how when you might do that. Let's say that we wanted to find rides in the initial data frame that had fares that were highly above the average for their pickup and drop off locations. So to do that, you can compute the mean fare and the standard deviation of the fare per pickup and drop off location, and then broadcast those means and standard deviations back to the original rows of the data frame so that you can compute a z-score for every ride fare relative to its pickup and drop off location. So these two cells are computing the per group mean and standard deviation of the fare. And then this one is broadcasting those group mean and standard deviations back to the rows of the data frame using the broadcast method of the group by object. This permute equals true keyword just means put the group or put the values back in the original order of the data frame. By default, they come out in group sorted order. All right, so then we take those things that have been applied to the whole data frame and we compute a z-score by just taking the fare of that ride minus the mean fare over the standard deviation plus a little offset to prevent dividing by 0. And then we can histogram those things. And rides with a high z-score represent fares that are well above the mean fare for that pickup and drop off location. So one of the probably the biggest workflow or most typical workflow that we see Arkouda users doing is they'll load a data set in Arkouda, explore it, do a group by or several group bys to transform it, perhaps a broadcast and a filter. They'll do something to generate a small result set that is small enough that they can just bring it back to pandas and work from there. And so this is how you would do that. Let's say you wanted to look at those real outliers in terms of the fare z-score, and you can select that with the z-score being greater than 15, and then use this little idiom dictionary comprehension to select those outliers from every column, convert it to a NumPy array, and then put all those NumPy arrays in a dictionary and make a pandas data frame out of it. So this will end up with just a regular old pandas data frame that you can look at. And there's some interesting stuff that you could look at in here, like what's the worst, these are some bad taxi rides, right? That took like 3 hours to go a quarter of a mile or something. And you could also do something like back in Arkouda, if you wanted the worst taxi ride, you can use the argmax method to get the index for the worst thing, and that dictionary comprehension idiom to pull out that data. So that's sort of the end of this brief tutorial. When you're done exploring data in Arkouda, because often you're running an Arkouda server on like an allocation from an HPC, so you don't want to take more time than necessary, you can call this ak.shutdown command, which will shut down your server and release, if you've launched it with Slurm or a job management system, it'll release those nodes and you won't get charged anymore. So, and other people can use the cluster. So on a laptop, it's not as important to do that, but just wanted to point out that it's there. Okay, so that's kind of the end of the tutorial. Happy to answer questions or show functionality that I might not have covered here if people want to see things.
So, hey, Bill, and Michael, thanks for the tutorial. This is Jeff. I was just wondering, back to HDF5, is there a way to open the data remotely on the server where the Arkouda is running, in case it's a really large data set, so that you could open it remotely and not have to pull it in to the front end?
So
Or maybe
this command actually does open it remotely.
Okay.
Yeah. So anytime you call an Arkouda command, well, maybe I can't say anytime, but almost every Arkouda command that's in the Arkouda module is going to execute remotely on the server. And yeah, so this is the converter up here that ran just in Bash as a process on my laptop. It produced the HDF5 file, and then we came back into Arkouda. And when you give it when you call this ak.readAll function and give it a path, the Arkouda server goes and finds that on its file system and loads that up remotely.
Okay, good.
Mm-hmm.
So Jeff, this is kind of an interesting point in that this string that you give ak.readAll can actually be a glob expression. So, and that's how we use it normally. We'll have a directory full of, a day's worth of data in many files. And we'll do like, trip data, 2020, instead of like -01, we might do dash ? Dash .hdf or something. And then that will suck in all the files that have, 2 characters in that position, or, some sort of glob expression. And the read all can actually read multiple files at once and concatenate them together, basically in an array.
Cool. And is that spread out? I mean, is that striped across the different servers initially, or does it all read in one server? Okay.
Each server is responsible for a file at this point. So if you give it a list of 100 files and you have 50 nodes, each server is going to read in 2 files.
Each node of
each node is going to do that.
And then were you asking about like striping on a Lustre file system?
No, yeah, just generally how, I was just worried about the memory capacity of the initial node on the IO, if there was any limitations there in terms of pulling it in and then redistributing it across the many nodes. But it sounds like you do that with the files.
Right. Yep.
Okay. Thanks.
Yeah, and even if you give it a single file, for a multi-node Arkouda server to read a single file, it will each node will read its own chunk of the file into its own memory. So you don't really get memory spillovers on.
Okay, good. Thanks. I have more questions about the way that it's built and lowered to Chapel on the back end, but I guess that's what we're going to talk about tomorrow, right? So
yeah, that's what we're going to talk about tomorrow.
I'll save those questions.
I'm going to pull a thread. From like a notebook all the way through to the back end and then back to the front end. Right. So we're going to look through the code path. Basically, that's how I'm going to organize it.
That'd be great.
So Bill, you want to, I know you stopped your server, but we got a couple minutes left, and there are actually functions. There's over, I think I did a count of like how many functions and type combinations there are, and there's over 400 function and type combinations in Arkouda now. I mean, there's probably over 500 actually, but you can query from the notebook. You can actually query the server, and it sends you back like the configuration of what the server is actually running on, and you can get like an estimate of how much memory is being used across the cluster and various other things. So,
cool. Do you want to see that?
Yeah. Why don't you start up a server and reconnect, and then we could do an on-the-fly insertion of a cell.
Yeah, and I had a question was, when you're adding columns to the dictionary by, adding some of those things, is there a way to clean back, if you kind of say, yeah, I'm starting to use up memory, I want to clean out some of the additional columns that I've added, of data. There's an example of that.
Sure, yeah, you can actually just use Python's facility for deleting dictionary values. And when an object, when an Arkouda array, its object representation in Python gets deleted, the Arkouda server will delete the array and free up the memory. Now, sometimes you run into tricky issues with the Python garbage collector, especially in its interaction with Jupyter Notebooks, and it doesn't always free it up right when you think it's going to. But in 90% of cases, if you just delete something out of an Arkouda data dictionary, or if you delete an Arkouda array on the Python side, it'll free the data. I guess I could show. Well, I stopped my server, so I don't have the data loaded anymore. But I could load that and show an example. So there's this get mem used function that shows the memory currently used by the Arkouda server, by all the arrays in its symbol table. So if I do,
are you running with the memory flag turned on?
I'm not sure.
Okay. If you are, it will query the Chapel runtime and see how much memory you're using.
So I just deleted one of the columns of this data dictionary, the payment type column, and you can see the mem used went down by 50 megabytes, corresponding to the freeing of that column. And then what Mike was asking about before is this: you can run ak.getConfig, and it will show you some of the attributes of the running Arkouda server. In particular, how many nodes it's running on. So I'm just running on my laptop. How many essentially CPUs per node, things like that. The amount of physical memory total available to the Arkouda server. And then it'll show similar statistics for each node.
Yeah, that locale configs is an array. If you have more than one node, it'll be an array of all of the configs of all the locales. Do you want to say something about maybe about the logging, or I don't know? It's fine. We keep a trace of execution.
Yeah, I can show you what the server is printing out when we're running all these commands. The server is pretty chatty, and it'll fill up your terminal window pretty quick. So this is an example of just since I started the second Arkouda server and just ran those couple of commands, this is what it's printed out here. So for example, here's the call to ak.readAll, and it's going through and it's reading the, I guess, 18 columns of our data frame. And every time that the memory reaches a new high, it'll print out this thing, memory high watermark, so that you can look at how the memory is growing compared to the limit of the of what the server can allocate. And then, for example, we're really diving into. I won't parse out another.
Yeah, that's fine.
And I'll let you do that tomorrow, Mike.
Yep.
But yeah, these are all just messages that command output that fly back and forth as messages get sent from the client and the server.
So we're actually engaging in a little bit of data science on our data scientists. Right.
Yeah,
That's the reason why we keep these traces, so we can understand what's the most used operations and various other things. So we keep traces of all the executions. You can turn the trace off by on the command line saying -- trace equals false, I think, because it's a Boolean.
Naive question.
Uh-huh.
Can you guys share them traces?
No.
All right. Okay.
Not the real traces.
Because, I mean, that would be actually very useful information. Okay.
Yeah. I mean, we're interested in things like, inner arrival time. Like, what is the behavior of an analyst who's sitting there at the Jupyter notebook, and how long do they think versus how many commands do they run in a row, like in rapid succession, like if they're executing a particular cell or,
All right. Yeah, I mean, I was curious about, I mean, these traces tell you a lot about the kind of the program structure and the way people architect their code, and it would be useful to understand, I mean, give you a path to optimization or better optimization.
Yeah, there is a lot of good information.
Codes, that would be the next best thing, though.
Uh-huh.
Are you trying to become the next Jeff Bezos there, Mike? Analyzing your workers?
I don't know. I'm not. I'm
just giving you a hard time.
We implemented it because we had a data scientist that was interested in analyzing the behavior of the data scientists who were using the package, right?
Yeah, no. And especially for a very high level, the way that you've talked about your use case, that seems to make sense, right? So
yeah. Yeah, it also gave us a real leg up on understanding what people were using the most and actually trends in their behavior over time. So we have traces that are a year old versus new traces, and it's the workflow has changed over time.
Right.
Bill can talk about that a little bit, but we don't want to go into too much detail about it, obviously. But
yeah, I think it's safe to say that in the very beginning, we were co-developing Arkouda with the sort of birth of this whole mission project inside of our organization. And in the beginning of that, people were mostly loading up a big data set and doing simple summary statistics and histogramming things and filtering and doing existence checks. And over the course of about a year, people slowly transitioned from doing that basic kind of thing to loading up smaller data sets, but doing much more complex things on them. So we saw that as like a giant increase in the amount of internal state generated in the course of the running of a notebook, and a lot more execution time being spent on things like group by. So it was kind of cool to see that. We also saw these large blocks of server commands that would execute within 10 milliseconds of each other, which we presume to be people writing functions, composing functions in Arkouda out of more basic Arkouda primitive operations. And so, once we saw that, we were like, okay, people are starting to go to town, building more complex functionality on top of what exists there. So people built like breadth first search and connected components for graph exploration, stuff like that.
Yeah, well, and it also sounds like it'd be incredibly useful for targeting next gen functionality as well as optimizations and all that sort of stuff. Yep. So that's great.
Yeah, this is, we're a little bit over time now, but basically this has allowed us to figure out what to target. So there's sort of 3 or 4 levels of how Arkouda functionality gets implemented, right? So there's base Arkouda operations that already exist. And then people figure out in Python how to string those together. And then we look at that and we say, oh, is there a higher level or a more complex operation we should be implementing? You know, and you can think of the messages that go back and forth between the client and the server as the instruction set, right? And so we can basically add to the instruction set over time. And we have, like, we had in particular, we had a set of set operations on arrays, like set union, set intersection, set difference. And those last summer, those went from being pure Python with Arkouda operations, and they averaged 5 to 10 Arkouda server operations each. And Google Summer of Code person that worked for Brad and those guys moved all of those operations into the server for integer types, right? So, and that sped everything up by a factor of 2 or 3 on average. So,
hey Mike, is the Arkouda notebooks repo publicly?
it is public. It is
Okay.
public.
So we've got a couple questions in the chat asking if we could share the code. So there's a sibling repo to the Arkouda GitHub repo that's called Arkouda Notebooks, and the code, the notebook that I showed today is in there.
Yeah.
With the data set?
It's
No,
got
the
a link. It's got a link to the data set.
Okay.
Yeah.
And the data set, the New York taxi cab data is an open data set. So you can follow that link and get the file, or you can get into the directory. If you glob together all of the like 2019 data, it's over 1 billion taxi cab rides. Right. So it's an interesting, you know, it's not as big as some of the other things we've looked at, but it's one of the biggest things when in aggregate, it's one of the biggest things that we've been able to show people on the outside. Besides like the LANL net flow data from 2017, you can look at that, and there's a notebook in the repo that scratches that a little bit. That was one of the first data sets that we sort of made examples of. Anyway, I think that, you know, our hour is up, and you know, I'm sure everybody's head is full. If you have questions, the Arkouda Notebooks repo, if you want to put issue in there and ask a question, we could have a discussion like on the repo, right? In the issues section of the repo. There's also a couple of examples in the actual Arkouda repo and in the examples directory. But the notebooks I've tried to push into this notebooks repo because they need a little special handling. It sort of pollutes the the code, the repo with the code in it, right? So it's just a personal preference of mine. Anyway, it's an issue. We can just talk about it sometime. But I think that's pretty much it. We could do this again if somebody wanted a deeper dive. But I really appreciate everybody showing up. I think that this has been really good. Thanks, Bill. Bill did a great job, I think.
Yeah, thanks, guys. This was great.
Thank you all.
Thanks.
All right.
Thanks.
Okay, we'll see you.
Yep.
Have a good day.
All right, thanks.